Homework 3.1, Quadratic Functions, Video 3. Homework due Wednesday, May 27th, 2020 at 11:59 p.m. The following video correlates specifically to homework question 14, but there are other problems within the homework that also include this. The same can be said about the first two videos about finding the vertex. Questions 1 through 4 are specifically find the vertex, but there are other questions that also incorporate that knowledge. All right, so in this video we're going to talk about something called the axis of symmetry and what I have dubbed symmetric images, basically the mirror image of one point or part of a graph across the line of symmetry. You'll notice on the board we've already got the same function that we dissected at the end of the last video. Specifically, we found the x-intercepts, we found the y-intercepts, and we ended up finding the vertex. So let's just say that we recall those things. The y-intercept is y equals 8. X-intercepts are x equals 2, x equals 4, and the vertex is 3, -1, all stuff that we found out in the previous video. So I can put an 8 up here. Actually, let's put the point 0, 8. I've already got the vertex labeled at 3, -1. The x-intercept on the left is 4, 0 if we write it as an ordered pair. And the x-intercept on the right, the one on the right is 4, 0. The one on the left is 2, 0. So we already found all that out in the previous video. But every parabola has what is called an axis of symmetry. Loosely speaking, an axis of symmetry is a line that splits a graph or an object in two, where one side is a mirror image of the other. As we kind of alluded to in the previous video, the axis of symmetry for a parabola drops straight down through the middle. So in your homework, one thing you're going to be asked to do is to come up with its equation, but it's a vertical line. So if you go back to homework 2.3 in the videos there. In fact, if you go back to the module over homework 2.3, you'll see a video specifically titled Horizontal and Vertical Lines. So if what I'm about to say doesn't sound familiar, go back and watch that. But being a vertical line, the equation of this is x equals. X equals what? Well, it goes right through the vertex, and on the vertex, x equals 3. So when you're asked for the equation of the axis of symmetry, it's always going to be x equals a number, and that number is always going to be the x-coordinate of the vertex. So it's not something you have to calculate extra, it's just an observation that you make. Oh, your vertex is 3, -1, so your axis of symmetry must be the line x equals 3. But instead of just saying there's the axis of symmetry, I want to show you how to use it to actually generate more information to help sketch a graph. Now I know this one is already sketched, but let's say that we wanted more dots on this side, on the right side, because on the left side we had 2 dots to connect, but not on the right side. The axis of symmetry serves as a mirror. Everything on the left side has what I call a symmetric image on the right side, and vice versa. For example, take a look at our 2 intercepts on the x-axis. Each one of them is one space away from the axis of symmetry on this graph. They're not always one space away, but they're always equally spaced from the axis of symmetry. So the mirror image, or the symmetric image of 2, 0 across this axis of symmetry is 4, 0. Anytime you have one point that's not on the axis of symmetry, the vertex being the only one, it has a mirror image on the other side. Well, look at the y-intercept. Can we find its mirror image over here? In other words, if I take the mirror image of the point 0, 8 across the axis of symmetry at x equals 3, what will its ordered pair be over here? Pause the video and see if you can figure out where that is. Everything you need is up here. You know where the axis of symmetry is. You know where the y-intercept is. And you know that there are mirror images across the axis of symmetry. All right. I know about this mirror image, this symmetric image, is it has the same y-coordinate because it is up the same amount as the y-intercept. So I know it's up 8, but what's its x-coordinate? Well, a point and its symmetric image are equally spaced from the axis of symmetry. So if we can figure out how far apart it is here, we can just go that distance in that direction. And how far from the axis of symmetry is this y-intercept? That far. And how long is that far? 3. In fact, whatever your axis of symmetry equation is, that is telling you how far away the y-intercept is in terms of horizontal displacement, 3 to the left, which means its mirror image would be 3 to the right. So to get from here to here, we would have to go over 3 to get to the axis and over 3 more, which would put it at 6, 8. Now, we could make this generic by replacing the numbers with A's, B's, and C's. Not going to, but I'll throw a bonus question at you. Here's your bonus question. For f of x equals ax squared plus bx plus c, what are the coordinates of the symmetric image of the y-intercept? And I'll tell you how to approach it generically. In this specific problem, x is equal to 3 because it was the x-coordinate of the vertex. But in a generic problem, what's the x-coordinate of the vertex? And in this problem, the y-intercept was 8 because that's what we got specifically when we put in x equals 0. But what would the y-intercept for this be? And then think about how you got from here to here. Bonus points for the first person who can send me the coordinates of the symmetric image of the y-intercept. Challenge yourself, you might be surprised. All right, so let's just practice finding one more mirror image. I know that there aren't any other points up here, but we can make points all day long. All we have to do is pick an x value and stick it in. Well, I know what happens at x equals 0, x equals 2, x equals 3, x equals 4, x equals 6. Let's see what happens at x equals 5. So this is a supplement to what's already happened. In order to find the symmetric image of the point at x equals 5, I got to figure out its y-coordinate, but that's just sticking in 5. So 5 squared minus 6 times 5 plus 8. This is 25 minus 30. That's negative 5. Negative 5 plus 3 is, negative 5 plus 8 is 3. So the point 5 comma 3 happens to be on this particular parabola. Do you know where its symmetric image is? Think about how far from the axis it is. The axis is at x equals 3. This point is at x equals 5. How far apart are 3 and 5? 2. So if this point is 2 spaces to the right of the axis of symmetry, then its symmetric image is 2 points, 2 spaces to the left of the axis of symmetry. I know it's the same y-coordinate because they're both up the same amount. But if the axis of symmetry is at x equals 3 and I go 2 spaces to the left of that, what would the x value be? 1. Finding symmetric images with respect to the axis of symmetry really isn't that difficult. You just have to, whoa. It isn't that difficult, except when I screw it up. This is not the point 1 comma 5. What should it be? Let me say it again. It's not 1 comma 5. How far up is this point? 3. So how far up should this point be? 3. I've said it before and I'll say it again. It does not matter how good you are or you think you are at anything. The best of the best, and I'm not saying the best of the best, can and will make casual mistakes. That was me being careless. That was me thinking in advance of where my brain was at the time, or where my mouth was at the time. So my apologies, but this should be 1, 3. The symmetric image of 5, 3 is 1, 3 on this particular parabola.